This is the last little bit of new learning that we have for this unit. We're going to apply these problems or these strategies in more complicated problems in the next lesson, but we need one more piece of brand new information, new learning. So that is how to find an angle size of an angle in a right angle triangle using a trig ratio. And our trig ratios are still the same as always, right? We are still going to use SOHCAHTOA to help us figure out what we need to do. So let's take a look at the size, or the question where we have to find the size of angle G. This is angle G right here. And relative to angle G, we have this side length here, little h, which is 6. And it should have units. It doesn't, sorry. So it doesn't really matter for our purposes, but it should have units. So it has 6, and h relative to angle G, little h is the adjacent, right? And we've also got this length here that's 14. Okay, 14 what? I don't know, but we've got 14 here. And 14 is little k. Little k is 14, and that happens to be our hypotenuse. So relative to angle G, we're given the adjacent, we're given the hypotenuse. We have to figure out how big G is. So go back to SOHCAHTOA. Which of our 3 trig ratios tells us information about the adjacent and the hypotenuse? And that's cosine. So cosine is the adjacent divided by the hypotenuse. So that's what we're going to use. So we start by writing our structure. Cos theta equals adjacent over hypotenuse, right? To show that we know the correct ratio to use and how to set it up. And again, we never ever forget to say cos of theta, right? We don't never say cos equals. We always say cos of theta equals. I'll put that into focus for you. Here's cos of 6 over 14. So we're asking our calculator, when we put this in our calculator, I'll get ready. When we put this in our calculator, we're saying, hey calculator, if the opposite is backwards, and tell me what angle creates that. Okay, so for my calculator, and again, everyone's calculator is going to be really different, so you might have to play around for a bit to figure this out. I have to press Shift Cos, and then I get this inverse cos, which is wonderful. Like this double display calculator is fantastic because it shows me exactly what I've asked it to do. And then I'm just going to go 6 divided by 14, right? If you'd like, you could do inverse cos and 6 over 14. You could put it in as a fraction if you like. My fraction button looks like this guy. Yours might look like an ABC, but honestly, at the end of the day, you really just need to do 6 divided by 14. For those of you who have to press the number first and then the ratio, you might have to do 6 divided by 14, get that ratio, and then do the inverse cos of that, right? Inverse cos of your answer. Okay, so however your calculator works, 6 divided by 14, you should get G equals 64.62 degrees. Okay, so play around with your calculator until you can get your calculator to consistently give you that number. Okay, so 64 degrees. All right, and it's kind of hard to know if that's a reasonable number, right? But at least it's a degree. Sometimes students forget to do the actual cos ratio because their calculator works a little weird. Like an angle size would never just be 0.428, right? So we always want to make sure that our number makes sense and it kind of fits the context of the problem. Let's do one more. See what's going on here and then this next problem. We're looking for angle N. need to take a look at the information that we have relative to angle n. So for in this question, we have 13, which is opposite of angle n, and we have 9, which is adjacent to angle n. So going back to SOHCAHTOA, I hope we can see that that's our tan ratio. So let's write it out like we're supposed to. Tan theta equals opposite over adjacent. In this case, we're looking for n, so tan n is, opposite is 13, adjacent is 9, and n is going to be the inverse tan of 13 over 9. Okay, so try that in your calculator, and I will in mine, and we'll see if we get the same number. Okay, we should get n equals 55.30 degrees. Okay, so again, you want to make sure you're in degree mode, and you want to make sure that you're using inverse tan because we're looking for an angle size. We use just straight tan when we're looking for a side length, but inverse tan for an angle size. Okay, let's do a quick problem, because really trig is actually used a lot in problem solving. If you do any kind of construction work, you might need to calculate angles using trig. So we're going to ultimately solve a lot of problems, like word problem kinds of questions. So in this problem, we're given a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It's attached near the top of the pole. What angle does the cable make with the ground? Well, with every single word problem, for the most part, I guess, I always just find it way easier to start with a picture. So here's my telephone pole. It's a silly telephone pole. There's a reason I don't teach art people. And there's a cable that's anchored to the ground, or the cable is 19 meters long and it's attached to the top of the pole. So there's our cable. The cable is 19 meters long, and we're 5 meters. This part where it's attached to the ground is 5 meters away from the pole. Here's our pole. Okay. What angle does the cable make with the ground? Well, this is the angle that we're looking for. Okay. And because we're not given a letter to use, I think the variable we should use is theta. So make a decision on what ratio we need to use to solve for theta. So theta is, where relative to theta we have 5, which is the adjacent, and 19, which is the hypotenuse. So we're using cos. So cos theta equals adjacent over hypotenuse. Cos theta equals 5 over 19. Therefore, theta is the inverse cos of 5 over 19. And when you put that in your calculator, you're going to get 74.7425 degrees. Okay, so now what you can do is you can solve for any piece of a triangle, a right angle triangle, as long as you're given 2 other pieces of information, right? Either you're given 2 side lengths and you need to find an angle, or you're given an angle and a side length and you need to find another side length. Okay, so now we can fill in that any right angle triangle. As long as we have 2 pieces of information, we can fill in the rest. Okay, all right, right on.